Hello everyone, welcome to Nam's World. In today's video, we'll learn about tree data structure. So this will be the part 1 of the video, and in this part, I will explain the basic structure of a tree and its application, terminologies, and about some rotations and balance factors I will discuss in this video. In the next video, we'll see the implementation of tree data structure. Okay, so let's move into the video. So, what is tree data structure? It is a hierarchical structure for storing a data, for numerous data, huge amount of data. Like, see, tree data structure means what? So, data అనేది ఒక ట్రీ స్ట్రక్చర్లో స్టోర్ అయి ఉంటుంది. So, data will be stored in a tree structure. This is a hierarchical structure used to represent an organized data in the form of parent-child relationship. It has parent-child relationship. I will show you the diagram. So, means in a tree structure, in a hierarchical structure, we will be storing the data. So, let's say the daily life application and the normal application of a tree data structure. Suppose you consider your computer. In computer, you will be having numerous data. Means what? Files, folder, photos, videos, numerous data. చాలా ఫైల్స్ ఫోల్డర్స్ ఉంటాయి కదా. సో అవి ఎలా అరేంజ్ చేస్తాం, ఎలా ఆర్గనైజ్ చేస్తాం, హౌ వి ఆర్గనైజ్ దెమ్ and represent them. We can represent them in a tree structure. So let's see, if you consider a computer, in that drives you will be having what? Folders. In folders you will be having files. So in a tree structure, means in a hierarchical structure, we are arranging those. So if you consider a general daily life example, like using Facebook, Instagram, in that how this tree data structure is used is, suppose consider you as the node. Okay, you are the node. You have some connections to your friends. Your friends have connection to other friends. So one node is connected to another. One parent, child, and subchilds. This like tree is very important. Most of the social media apps, application websites, they use this tree data structure. So data structure is very important. It is important in your placements also. Okay. So let's next see the tree structure and the terminologies. So as you all know, trees look like this. So this is the root node. Starting node is the root node. And these are the child nodes. Okay. Child nodes. A root node can have number of child nodes. Okay. So if you consider this as a tree structure, this is the root. See, which don't have further nodes, like these are the leaf nodes. Okay, these two are sibling. Means for a single parent, if two child are there, these are siblings. Similar way, these can be siblings. These two can be sibling. This is a subtree, because we have, suppose we consider as a root node, these are the child nodes. So this can be what? A subtree. These are leaf nodes. We have levels in a tree. See, root node first, this is level 0. Another, this step is level 1. This step is level 2. This step is level 3. So this, like this, we can have many levels in a tree. So now let's see how to construct a tree when the data is given. Suppose you're given the data, like suppose 15, 7, 9, 4, 7, 22, and 10. Okay, 5. This like your data is given. How you will construct this? Always remember the starting number will be the root node. And the next number, how you need to compare it with the root node. Now suppose if we take 7, compare it with 15. Is 7 less than 15 or greater than 15? If it is less than 15 or root node, then you should draw it in the left side. If the number is greater than 15, then you need to draw it on the right side. So next number is 9. 9. 9 less than 15 or greater than 15? 9 is less than 15, right? So you need to move to the left side. When you come to left side వస్తే ఏం ఫేస్ చేస్తారు? 7. 7 కంటే 9 small number or big number? Big number, right? So 9. Compare చేస్తూ రావాలి. You need to compare it. Like, see, first 9. 9 less than 15. Small number, right? So left side. 9 greater than 7. So right side. Next number 22. See, 22 is less than 15 or greater than 15? It is less than 15. So we need to write it on right hand side. Okay. Next 10. 10 is less than 15. So left side. 10 is greater than 7. So right side. 10 is greater than 9. So write it on right side. Next 5. 5 less than 15. So left side. 5 less than 7. So need to write to the left. Okay. Next we will see about balancing factors. If we have the numbers like 1, 0, -1, then we consider as the tree is balanced. How to calculate the balancing factor means left minus right. So see, if you take 10, what is the balancing factor of 10? 0, because it don't have any child or like nodes, like edges it don't have, so it is 0. Next, if you consider 5, this is also 0 because there are no leaf nodes. Here also 0. So now let's see how to balance this using rotations. So there are basically 4 rotations we have. First one is LL. Second one is RR. Third one is LR. Fourth one is RL. Okay. First, let us see about LL rotations. LL rotation, right? How you will consider this? Take a root node. Let us consider A. So L, right? L, left side. L. So let's see the balancing factors of this. So it is a leaf node, right? So see this. Now this balancing factor is 0 because there is no leaf nodes for it. Next, for B, how we will be calculating left minus right? Left side we have one node, right side do we have no right? So 1 minus 0 is 1. It is balanced. For this A, so in left side how many nodes we have? 1, 2, 2. In right side do we have anything? See, we don't have anything, so 0. 2 minus 0, 2. So uh, what are our balancing factor? 1, 0, minus 1. 2 is not in the list, so we need to balance this. How we can balance this? You need to LL means you remember this. Right side ki move cheyali. A ni right side ki move cheyali. You need to move the A to the right side. So ఇలా మూవ్ చేస్తే ఏమవుతుంది చూద్దాం. Now let's say the balancing factor for this. Leaf node row. So 0. 0. See, 1 node. 1 minus 1 was 0. So it is balanced. So next let's see RR rotation. LL means we did right rotation. RR means we'll do left rotation. Okay. So let's take a node A. right side, right? So R. For this right side, see, R. Okay? See, in the previously we did LL rotation means right side we rotated. Now RR means left side you need to rotate. That's all. Why we are rotating this? Let's check the balance factors first. So the balancing factor for C is 0 because there are no nodes, subnodes. So here for B, left node, do we have anything? No, right? So 0. Right side we have 1. So -1. Balance. See this. In the left side we don't have any nodes, so 0. In the right side we have 2 nodes. So 2 -2. We don't have -2 in our list, so it is not balancing. We need to balance it. So for that we need to do left rotation. RR means left rotation you need to do. See. ఈ B ని ఇక్కడ పెట్టాలి. ఓకే, B, A, C. Now check the balancing factors for this 0, for this 0. For this 1 -1 is equals to 0. So next let's say LR rotation. LR rotation means take a node L. First one left. So left side we need to draw a L node B. Next right side. So R. So see, I will say the trick to remember this. Okay. Basically, we have some formula like right rotations RR plus LN. We need to follow this. But let's say the trick here, okay? First, what you will do is, see, left side you have, right? Starting with left side. Left side start అవుతుంది కాబట్టి సో దీన్ని కూడా లెఫ్ట్ సైడ్ కి తీసుకొని వద్దాం. సో మనకి ఎల్ఎల్ రొటేషన్ వచ్చేది, తర్వాత బ్యాలెన్సింగ్ ఈజీ అవుతుంది. సో సి, సో దీన్ని బ్యాలెన్స్ చేయడానికి ఈజీ అవ్వడానికి మనం ఎల్ఎల్ రొటేషన్ గా కన్వర్ట్ చేయాలి. ఎల్ఆర్ ఇచ్చారనుకో, ఫస్ట్ ఎల్ ఉంది కాబట్టి దీన్ని కూడా ఎల్ గా మార్చేద్దాం. విల్ కన్వర్ట్. సో ఫస్ట్ ఇట్ ఈస్ ఎల్, రైట్? వీ విల్ కన్వర్ట్ దిస్ ఆల్సో టు ఎల్, లెఫ్ట్ సైడ్. సో అలా కన్వర్ట్ చేయాలంటే ఈ రెండింటిని ఇంటర్చేంజ్ చేస్తేనే అది కన్వర్ట్ అవుతుంది. ఇది రొటేట్ చేయాలి. ఓకే, వీ కెన్ డూ దిస్ లైక్ ఏ. So we need to interchange this two. So A, C. E, C ni we are interchanging, right? So this two will be interchanged. Now see L, L, LL rotation we got. We know how to convert LL. LL వచ్చినప్పుడు right rotation చేయాలి ఇలా. So C will be in middle, B, A. Now see, ఇంత చేసాం కానీ అసలు ఎందుకు ఇలా చేస్తున్నామో తెలుసా మీకు? ఎందుకంటే ఈ ట్రీని బ్యాలెన్స్ చేయడానికి. సో ఇవి బ్యాలెన్స్ అయిన ట్రీ కాదు, ఎందుకంటే ఇక్కడ బ్యాలెన్సింగ్ ఫ్యాక్టర్ 0. ఇక్కడ ఫర్ బి 0, ఇక్కడ ఏం లేదు కాబట్టి 0. ఇటువైపు 1 ఉంది కాబట్టి 1. సో -1. ఇక్కడ ఏంటి, ఇక్కడ ఎన్ని నోట్స్ ఉన్నాయి దీనికి? 1 2 2 ఉన్నాయి. రైట్ సైడ్ ఏమైనా ఉందా? లేదు కాదు. సో 0. ఇక్కడ 2 వస్తుంది. దీన్ని బ్యాలెన్స్ చేయడానికి ఈజీ అవుతుంది కాబట్టి దీన్ని ఎల్ఎల్ గా కన్వర్ట్ చేసాం. ఆ ఎల్ఎల్ ని మళ్ళీ ఆల్రెడీ మనం చూసాం కదా, ఇక్కడ బ్యాలెన్స్ అవ్వలేదు, సో ఇలా కన్వర్ట్ చేసాం. కన్వర్ట్ చేస్తే ఇది కన్వర్ట్ 0 0, ఇక్కడ కూడా 0 వచ్చేది. సో బ్యాలెన్సింగ్ అయిపోతుంది, ఎందుకంటే 1 -1. ఓకే, నెక్స్ట్ సేమ్ అలానే ఆర్ఆర్ రొటేషన్, సారీ ఆర్ఎల్ రొటేషన్. ఫార్ములా బేస్డ్ అయితే ఫస్ట్ ఎల్ఎల్ ప్లస్ ఆర్ఆర్ ఎల్ఎల్ ప్లస్ ఆర్ఆర్ చేస్తాం, కానీ మీకు ఈజీ వేగా చెప్తాను నేను. లెట్స్ సీ.
Thanks for watching. If you like the video, please like, subscribe, and share for more such contents, and comment something cute.